The keys to the deep decarbonization transition are what we refer to as the three pillars. And what we found is that across all scenarios that we built, all three of these pillars are required. And those are energy efficiency, decarbonization of electricity, and the switching of end uses, everything from cooking to driving, away from direct combustion of fossil fuels and toward electric sources. By electric sources, I mean electricity and also fuels that are derived from electricity, such as hydrogen that is burned in fuel cells. In addition to electric sources, sometimes there are other low carbon fuels, such as biofuels, that can be substituted for fossil fuels. What this slide shows is, on the bottom row, is metrics of how far you have to go to be able to achieve deep decarbonization, showing 2014 and 2050. The energy intensity of GDP, which is a measure of our energy efficiency, has to improve by a factor of about 4. Electricity has to be decarbonized by about 97% compared to our current grid. And at the same time, the need to electrify what are currently fossil fuel combustion end uses means that the share of electricity and electric sources in final end use energy is over 50%. So in other words, we're today under 20% of all the things we do with energy is done with electricity. We're going to have to greatly expand the use by mid-century. In the Deep Decarbonization Pathways project, we did this analysis for 16 countries. And I want to illustrate here a result that was found in 3 of those countries, China, India, and the United Kingdom. And what you can see is that all 3 of those pillars are also required in the same way in those countries that they are in the United States. This is not a United States specific result. This is a universal result because, in a sense, it's basic physics. The way that you achieve emissions reductions is by reducing energy use as much as you can for the services that you require, and then powering that with the lowest carbon fuels that you can. And the one that we think we probably have the most control over is electricity, because we really know how to decarbonize that sector. Therefore, you have to use a lot of electricity. And then things that are difficult to decarbonize, you may need to use other low carbon fuels for. So that's a universal result. Let me illustrate how all 3 of the pillars work together with this figure here. So this shows the transition in light duty vehicles between now and the middle of the century, again for the mixed case of the US DDPP. If you go across these row by row, what you see, first of all, is on the top row, between now and mid-century, this is total vehicle miles traveled. That's how much we are driving around in the United States. As I said earlier, our scenarios are all based on forecast of the US government. So this is the EIT's long-range forecast. So what you see there is, with population increasing, there is some increase in vehicle miles traveled. The question is, how do we deeply reduce the carbon that's emitted from those vehicle miles traveled? So the second row from the top shows you new vehicle sales every year between now and 2050. And what you see is that gasoline internal combustion engines have to go down very rapidly, while sales of hydrogen fuel cell vehicles, electric vehicles, and plug-in hybrid electric vehicles need to go up very rapidly. In the third row, what you see is the impact of that on vehicle stocks. As you add things in sales, the stocks change more slowly because there are some 200 million cars out there in the United States. So it takes a while for new sales to flow through to the stocks, typically on the order of 10 years. But if you start in the 2020s, making new sales an increasingly large share of your light-duty vehicles fleet, then by 2050, they become by far the dominant share. Then what you see is in the fourth row that because the vehicles are no longer gasoline internal combustion engines, the share of gasoline that remains in the system goes down and down, while the share of electricity and hydrogen goes up and up over time. In the fifth row, you see the actual amount of energy that's being provided by those things. And this is where the energy efficiency story comes in, because while the share of vehicle miles traveled that is taken up by electricity and hydrogen becomes very large, the amount of energy that they need to provide is relatively small because electric drivetrain vehicles are much more efficient than internal combustion vehicles. And so the actual energy needed is much lower than it is in the case of fueling those same vehicles with gasoline. And then finally, and this is really the bottom line that we're looking for, the emissions from light-duty vehicles in the United States go down very, very drastically, well over 95%. Most of those are from the tiny amount of residual gasoline use that's left at that time, and very little from the electric sources because electricity is almost completely decarbonized. This same kind of analysis goes into every sector and subsector and stock of equipment in our whole economy. But I think this illustrates it in a way that you can see the interactions between more efficient technologies, low carbon electricity, and switching to electricity and electric sources like hydrogen.